Welcome to Python Basics with EJD. In this video, I'll be talking about set operations in Python. In the general introduction to Python variable data structures, that is, I've talked about set and some operations we can do using set. Of course, don't forget that our integrated development environment has been Google Collaboratory. So one easy way to go is just type collab and it just takes you there straight. Of course, I have some lists already created. Set operations is the focus. So in this case, we have set operations in Python. So, of course, this is not the first time we are coming across set, right? We can actually define a set as an unordered collection of unique elements. So, unlike list and tuple, a set is unordered. But one beautiful thing about set is that it only contains unique elements. So, if you have repeated elements in a set, set will just take one and delete the rest, basically. So, if you want to avoid repetition, a set is a very nice thing to use. So if you're a software engineer, a data analyst or something, and you want to make sure that you want to store data in such a way that there's no repetition, then using a set is a very good way to go. So a set is another collection of unique elements, and it is represented by using curly braces or by using the set constructor. In the general introduction, I only used curly braces, but here you should also understand that you can use a set constructor to make a set. So using this now, let's see, how do you declare a set? First of all, you have fruits, you have apple, banana, and cherry. Don't forget a set is unordered. So because you wrote apple, banana, and cherry, does not mean that by the time you print it, you also have apple, banana, and cherry. It can be scattered, it can remain the same, it can be scattered. Anyhow it goes, you're good. Okay, so of course, usually when you run Google Colab the first time, it's a bit slow, but then after this, things pick up. So you have apple, banana, cherry. Thankfully, it comes out the same way. Of course, it's not like it matters anyways. So let me add something to it. Let me add guava, and then okay, this is ordered already. Then mango too, guava and mango. Okay, so mango. Okay, so I run it again. So you can see because it is unordered, mango has come first. The mango that was last has come first, followed by cherry, followed by banana, followed by apple and guava. So it's unordered. So that's one effect of it being unordered. Okay. So now if you want to use a set constructor, of course, that's a very long way, actually. So you can actually declare a list called fruits, all right? A fruit list containing all the mango, guava, and everything. So apple, banana, cherry, guava, and mango. So you have a fruit list. Then if you want to use the set constructor, you now say fruit set is now the set of that list you declared. So it's more like you're converting the list into a set. I think that's a longer way instead of just using curly braces and just getting over with it. So this now you now have, so you can see again it has also scattered it. It doesn't even follow what you had initially. So the first one was mango, cherry, banana, apple, and guava. Now it's cherry, banana, guava, mango, apple. So it's like there's no particular law because a set is unordered. So that's the unorderedness, if that word is allowed. Okay. So imagine you have numbers 1, 2, 3, 4, 5, 6, up to 10. So you can print that. That is a, so in this case, now that's also a set, right? So another thing we need to understand, of course, which I've emphasized even in the general video introducing variable data, variable Python variable data structures, is the fact that sets are useful for removing duplicates from a list. So if you don't want duplicates, like I said, go for sets. So imagine the fruit list is now apple, apple, banana, banana, cherry, cherry. And by the time you print fruits now, it only gives you apple, banana, and cherry. It removes all the duplicates, right? So once any item is more than one, it just takes one and forgets about the rest. So imagine talking about numbers now, we have 1, 1, 1, 2, 2, 3, 3, 4, 5, 5, 6, 7, 7, 8, 9, 9, 10, 10, 10, 10, like that. So by the time you just run this, it just removes all the duplicates and you just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So If you don't want duplicates, go for sets as a data structure in Python. Now, let's look at some set operations. Even in regular mathematics, we do most of these operations already. So set operations include union, intersection, and difference, and testing for membership of an element in a collection. Talking about union now, as the word implies, union combines all unique elements from two or more sets into a single set, right? And now the word unique is very important here. Maybe I should even highlight that, but it's okay. So okay, I think it's important to highlight it. So it means that it's more like so you have two sets, and then any element you can find in either of the sets or in both sets is part of the union. For instance, in fruit one now, you have apple, banana, cherry. In fruit two, you have banana, orange, kiwi. So in that case now, the union is going to contain apple, banana, you have apple in fruit one. Okay. You have banana in both. You pick banana ones. Of course, no sets cannot even contain repetition in the first place. Then you go for so union means every single thing you can find in both. You just pick it out. And the way to go for union is fruit union. You now say fruit one. This set now. Fruit one, union, fruit two. You use this I think this on my keyboard, this sign is on top of backslash. So I just press shift backslash and I get that standing thing like that. That's union. Or you have an alternative, which I'm going to do down here. So it's the same thing. So you have fruits underscore union equals fruit one union fruit two, using that as standing bar. And then if you print fruits now, it's only, and of course there's no order, right? So there's apple, it picks one. It picks apple. There's banana in both. It picks only banana ones. There's cherry, it picks it. There's kiwi, it picks it. And there's orange, it picks it. So this is the union. So as far as it appears in one or both of the sets, you have the union, basically. Of course, if you don't want to use this bar, you can just say fruit one dot union fruit two. So it's the same thing you get like that. For some funny reasons, it follows exactly the same order. But it doesn't have to follow the order though. So imagine you have medics, you have a group of medics containing pharmacist, gynecologist, nurse, and surgeon, and you have another group of medics containing radiologist, obstetrician, neurologist, nurse, and pharmacist. All right. So if you want to do their union, right, that means that means you're going to have one pharmacist, one gynecologist, a nurse, a surgeon, a radiologist, an obstetrician, a neurologist. Yeah, you already had a nurse and pharmacy, so you don't have to repeat them. So by the time you run this, of course, by the time you run this, you just have this. And it doesn't have to follow that very order. So you see pharmacist coming first, gynecologist follows, obstetrician is coming next, and then you have radiologist, nurse, neurologist, and surgeon, right? Of course, if you want to, you can also follow this. The alternative is you can say um medics one dot union, then you have medics two. So it gives you the same result, medics two, right? Okay, fine, let me just copy that out and do it in the next cell. So, okay, I run this with alternate enter so it can create a new cell automatically. So it gives us exactly, oh, in fact, this even brings it in a more organized way, right? So it brings it out in a very nice way like this, something going straight. Okay, so that's about union. Okay, what about intersection? Intersection returns a set containing elements that are common to all sets involved. So for the sake of intersection, we have the two sets, whatever is common to the two sets, that's all we need to work with. So in this case now, we have fruits. Okay, of course, remember the fruits, right? Apple, banana, cherry, banana, orange, kiwi. So banana is common to both. So if we take their intersection, we're going to have just banana as our result. So fruits intersection is now fruits. In this case, for intersection, we use and, right? We use and. And in that case, by the time we run it, we get only banana. So you can also say fruits, just like before, fruits dot intersection fruits. It gives exactly the same result. So for medics now, if you look at the medics one and medics two, what's common? We have Pharmacist is common and nurse is common. Nothing else is common. So you're going to have pharmacist and nurse when you run this now. Okay. Okay. You have pharmacist and nurse. So what happens, for instance, if okay, let me create a new cell. So what happens, for instance, if let's say I have okay, I have let me just say Africa. I have Africa. So in Africa, maybe I just want to have some countries in Africa, say Nigeria, Benin, Togo, and then Ghana. Okay. Then I come to Asia. I have another list, another set rather, called Asia. And here I have Japan, Korea, China, and Singapore. Okay. So imagine I have this. So let's look at some possibilities. Imagine I don't want to do uh say Africa, say Africa. Okay, we are still doing intersection here, right? Okay, so Africa dot intersection, intersection, Asia. So what do Africa and Asia have in common? Nothing. So if you run it, oh, it says name Nigeria is not defined. Okay, I think something is wrong then. Okay. Yeah, it's code now. How do we declare a set again? Yeah, think. Oh, I get it. These are strings. Just declared them. In fact, I should have wondered that they are underlined. So these are actually strings. So they are strings. I shouldn't treat them like they are numbers. They're actually strings. So that's a very learning a point of learning. So all these are strings I should know. So you can see putting quotation on them now. All the underlines under are gone. Yeah, so all this, so anytime you have your stuff on the line like this, you should know that something is probably wrong. Okay, so I was wondering why Nigeria is not defined. Okay, so now if we run this Africa intersection Asia, nothing is common. So you see, it gives an empty set because there's nothing common. So if nothing is common like that, you get an empty set, basically. Now let's talk about difference, which is also a very important point. When we come to when we talk about difference in set. So difference returns a set containing elements from one set that are not in another. So what happens here is that anything that is common to two sets, you cancel them out, and then now your final answer will now be whatever is left in the first set, very strictly the first set. Okay, so that's the idea of difference in sets. Okay. Um, all right. So in this case now, we have fruit one. You remember fruit one has a, okay, we have to go back to that again. Maybe I should just copy this so I don't have to keep checking it from time to time. So I have this now. We're talking about difference. So let me just put this here. So we have fruits one, apple, banana, cherry. I don't have to do this because the fruits are already declared. So I don't have to keep declaring, but it's okay. So fruits, apple, banana, cherry, fruits two, banana, orange, kiwi. And then I need fruits difference one. So in this case, now I want fruit one minus fruit two. What's the difference between fruit one and fruit two? So what happens is that for fruit one and fruit two, they have banana in common. So if you cancel the banana, whatever is left in fruit one is your answer for this difference. Now, so fruit one minus fruit two will be apple and cherry. All right. So that's exactly what we get. Apple and cherry like that. Okay. So then what about fruit two and fruit one minus fruit one? Because fruit two is coming first. After you cancel the banana, the answer is going to be orange and kiwi. So that's the idea of difference in set. So the first set seems to take the precedence. It takes the precedence like that. Okay. Um, Now, in this case, where we talk about the medics, for instance, okay, let me take this to another place. Now, I try to do something there as a way of by way of demonstration. So, of course, you can see as you know already, this is actually multi-line comments. This is multi-line comments just trying to explain what is really happening here. So you have pharmacist, gynecologist, nurse surgeon in medics 1. In medics 2, you have radiologist, obstetrician, neurologist, nurse, and pharmacist again. So what you're going to do is you cancel out whatever is common. So you have and pharmacist and nurse are common. So you cancel them out. So whatever is remaining in the first list, in the first set actually, is gynecologist and surgeon. So if you run this now, you get gynecologist and surgeon. Okay. If I let me use Alt Enter so I can create a new cell automatically. And in this case too, we have the same thing. We have this. We have this as a multi-line comment. That's lesson 5 where we talked about commenting in Python. Okay. So now that we have this, we want to find the difference between medics 2 and medics 1. So medics 2 will now come first now. So you have radiologists, obstetrician, neurologist, nurse, and pharmacist. Again, nurse and pharmacist are common. So nurse and pharmacist will go from the first place because they are also here. And your final answer will be radiologist, obstetrician, and neurologist. Okay? And that actually is the result you get in this case. Now, before we even go for membership test, right? There's also something called the symmetric difference, right? So I think that is also important. So I didn't have I didn't have a plan of including it initially under set operations, but I think it's important for us to know that too. So in this case, we have set operations include union, intersection, difference, all right? Difference, symmetric difference. Apart from difference, we also have symmetric difference, okay? And testing for membership of an element in a collection. That goes. So let's talk about symmetric difference. I haven't talked about difference on its own. So here now we have, okay, I think I just want a text box where we talk about symmetric difference. So symmetric difference. Okay. So for this now, I need like maybe 2 or 3 code boxes. So I'll use the same thing we've been using before. But before we even go, I think I need to also define what symmetric difference is about, right? Okay. I double click again. I need to write the story. So the symmetric difference between two sets, is the set of elements, that are either that are either that that are that are in either of the sets but not that not is important, not but not but not in their intersection, but not in their intersection. Okay, so that is the idea of symmetric difference. So in this case, using what you have used before, okay, I think we also need to know how we can declare this. Okay, I mean, in the other case, I didn't do this, so we just went straight to the example. So let me do the same here. So in this case, you use a caret or the symmetric difference method. So let's do that. For instance, okay, let me bring those two sets I've been using, Medics 1, Medics 2, and all of that. Here now, I have Fruits 1 and Fruits 2. Okay, I have Fruits 1 and Fruits 2. So for symmetric difference, So I bring this here now. Okay. So I have this here now, and I want to do the symmetric difference. We can use caret for this. So all I'll just do is say I want the let me say I want sim diff sim diff one. Okay. I mean, this is already giving us that. So I just accept everything. Let me accept everything. Yeah. So we see sim diff one. So we have fruits and we use this caret now. So, or we can use fruit dot one symmetric difference fruit two. So in this case, now what do we get? So if you run it, you see what you get. If you cancel out the banana, then the symmetric difference is every other thing in the first and the second set. Normally, the normal difference is you focus on whatever is left. Normally, the ordinary difference will be apple and cherry, right? After you cancel the banana. But yeah, you're going to have the apple and the cherry and the orange and kiwi in the next one. Okay. So, I mean, if you even do uh, symmetric difference too. Okay, let me just try that out. I know it doesn't, I know it won't really matter because since a set is unordered, I don't think it matters if you change the order because it's symmetric, so it will still contain everything. So I want to do symmetric diff 2. Of course, I need to change that here too. And then this now becomes fruit 2. Okay, and this is fruit 1. Okay, so we also change this. This is fruit 2 dot symmetric difference of fruit 1. So it's still going to be the same, basically, still the same cherry, orange, kiwi, because though this one is coming first, now it doesn't really matter that the order is changed, right? So you see, symmetric difference, as the name implies, is what it's called. Let me see, what is it called in algebra again? It's commutative, yeah. I think the idea is commutative. So whether you do it forward or backwards, it doesn't matter, right? So, of course, imagine for this now, what if you want to do the symmetric difference of this? They don't have anything in common in the first place. So the symmetric difference of two sets that don't have anything in common would just be like the union of the two sets, right? So here now, if I have Africa, Nigeria, Benin, Togo, Ghana, and Asia, Japan, Korea, China, Singapore, and I want to do symmetric. So let's say I want to do symmetric difference. I don't want to add any attach any number to it. And I just have Africa, Asia. Okay. How do I accept this? Okay. Oh, I can point at it and I accept everything, right? So Africa, symmetric difference, Asia. I just have, so it will just be like I'm listing everything together. So it's in this case now, if they have nothing in common, it's as good as listing all the countries 1, 2, 3, 4, 5, 6, 7, 8. That's what the symmetric looks like. So let me do the last one with the medics sets we've been working with all along. So I have this now. So since it's symmetric, right? Whether you do it forward or backward, it doesn't really make any difference, basically. So we can go for symmetric difference. So if you want to collect things that are not common to two sets, you can use symmetric difference. Okay, so here now, I also want to do the symmetric difference. So we do it for meds. Now I accept everything. So that'll just be after you've canceled that nurse and surgeon, whatever is left, right? Gynecologist, okay, for instance, pharmacists and nurses are common, so they are gone. So we have gynecologists somewhere, we have surgeon somewhere, we have radiologists, we have obstetrician and neurologist, and that's the symmetric difference. I think that's really important to take note of. So apart from that, you can also do a kind of membership test. So for instance, let me bring the fruits so that we can have it in view, so we can easily relate with that. We've not worked with fruits for a bit of time now. So let me just come back. So you want to test for membership of elements in a set. So I just bring fruit 1, apple, banana, cherry, fruit 2, banana, orange, kiwi. So want to check, is banana in fruit 1? In fruit 1, there's banana for sure. So in this case, now this test checks if a specific element exists in a set using the in or not in keywords. Okay, I need to put this in bold so that we can know what exactly we are doing, in or not in. These are the keywords we need to use here, in or not in. Okay, so in or not in keywords. So banana in fruit 1. Well, because banana is in fruit 1, that's going to give us true. the mango in fruit one, there's no mango in fruit one. That's going to give us false. So I run that and we have true, false for sure. Then again, banana not in fruit two. Banana is in fruit two, so banana not in fruit two is going to be false, right? Because there's banana in fruit two, then banana not in fruit two is going to give us false. We are saying, is there no banana? The banana is not in fruit two, and that is false. Mango not in fruit two. In fruit two, there's nothing called mango. So it means that that is actually true because since mango is not there in the first place. So if you run that, you get the true, the false and true like that. Okay, that's to check if something belongs to something. So if you, this is particularly going to be useful if you have a very large data set and want to confirm if you have a particular thing in that set. Okay, so mutability of sets. Now, sets are mutable. That means that we can actually um remove, we can note that sets are mutable, which means that you can add and remove elements from a set. So you can add and remove elements. Let me also make that bold. You can add and remove elements from a set. Add and remove like that. Okay. Can add and remove. So how do you add to a set? So if you have fruits, apple, banana, cherry, add an element to a set. So if you want to imagine that you want to add mango to this now, you have apple, banana, cherry. So fruit dot add mango. So to add mango, so you take the variable name of the fruit. So you have fruit dot add mango. So automatically, by the time you run it, you're going to have apple, banana, cherry, mango. Well, the mango doesn't have to come last. It can be anywhere because the set is unordered. All right. So if you run this now, interestingly, see the mango if you were to use append in list, the mango would come last. But here, the mango comes, it's in position two, going by Python order. So apple is 0, banana is 1, mango is 2, cherry is 3. Normally, cherry was 2 before, so banana should have been 3. But no, mango displays cherry because sets are not ordered. That's the idea here. So if you want to add something, so you do fruits dot add, for this one now. You have medics, radiologists, obstetrician, neurologists, nurse, and pharmacists. Now you want to add physiotherapists to it. So just medics.add. So the variable name is medics. Then the keyword is add. And then what are you adding? Physiotherapist. At the time you run this now, you now have physiotherapist added to that list. Now, if you don't want to add, maybe what you want to do is remove. So from that list now, you can see the updated list is apple, banana, mango, cherry. So whatever you have is the current state of the fruits. That's apple, banana, mango, cherry. So if you now want to remove banana from the list, right? So it means if you remove banana from this new list, now you have apple, mango, and cherry, and it doesn't have to come out in a particular order. So what you do here is you do fruits dot remove whatever you want to remove, that's banana. So if you run it now, banana is gone. So you have apple, mango, cherry, right? Apple, mango, cherry. Then imagine from the medics list, the current medics list, by the way, is pharmacist, obstetrician, neurologist, physiotherapist, radiologist, and nurse. And now you want to remove the obstetrician. So you're going to have pharmacist, neurologist, physiotherapist, radiologist, and nurse. And it doesn't have to be in that order, by the way. So we run that, and then obstetrician is gone. And we have pharmacist, neurologist, physiotherapist, radiologist, and nurse. So that's how to remove from a set. So it's been such a sweet experience learning about set operations in Python. So it's quite enriching indeed. So if you don't want duplicates in a data or something like that, or you don't want any duplicate to come, maybe you are designing an application and you don't want a particular part to not have duplications, this is what to use. Set is what you need to use. Thank you so much for listening. This is the end of the video. Let me know how helpful this is for you. Let me know in the comment section, either on Facebook or on YouTube. If there's something you'd like me to try out, feel free to let me know. Also, if you have subscribed already, thank you so much. If you haven't subscribed, I don't have to tell you, you are missing a lot already. So go ahead, hit the notification subscription button and subscribe. Then don't forget to hit the notification bell also, so you can always get alerted each time a new video is released. You can even make your experience better on this channel by clicking on join, and you become a member of the channel. And then we can even get to interact even at deeper levels than you just subscribing. Ultimately, don't forget to like, comment, share, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.